Okay, so I started recording this class, uh, and in this class we will go through different examples in node voltages method or nodal voltages method. So we need to solve different examples, and if you will be able to do similar examples that we will do in this class, you will be good in node voltage analysis. So let's start with the first example. So I'm doing the same examples that we have in the lectures. So the same examples. So we have this circuit. So let me see what we have. So here we have a current source, 4.5 amps. We have a 1 ohm resistor. We have a 12 ohms resistor. And here we have 4 ohm resistor. And the voltage source is 30 volts. And the top resistors are 6 ohms and 2 ohms. And we need to find the voltage between these 2 points. So we need to find the voltage, okay? So 4.5, 1, 6, 2, 4, and 12 and 30. Okay, so this is the circuit that we need to solve. This is the circuit that we need to solve. Okay, so first of all, I want to circuit more. So I will keep the current source, and I will do this resistance. As you see here, we have two resistances, and these two resistances are connected in series. And the resistances which are connected in series can be combined, and the equivalent resistance will be the sum of these two resistances. Then 6 plus 2, it will be 8 ohms. So when I'm using this combination, of course, I will not be able to find the voltage between these two impedances. But after solving this circuit, I will go back to the original circuit. So this is, I have 30 volts. I have here a resistor of 4 ohms. Here now the resistor is 8 ohms. This is 1 ohm, and this is 4.5 amperes. Is it clear so far?
Yes.
Yes.
Okay. So now we need to select the reference. We need to select the reference, and as it was discussed before, if you have, as you see, a voltage source, then it is better to select its negative terminal as a reference. Or the other option is to have 1, 2, 3, 4 components are connected to this lower essential node, while I have only 3 components connected to this, and 3 simple circuit elements are connected to this essential node. And as you may notice that we have 3 essential nodes. So this is one, this is the other one, and the lower one is an essential node, and this is one node, because we don't have any elements between these two points. So I will select this lower node to be the reference, and I will give this sign to show that this is the reference, and I will name this node as 1 and this node as 2. Then this will be plus minus V1 from the essential node and the reference, while V2 will be considered the voltage between the essential node 2 and the reference node. And here we have that resistance is 12 ohm. So let me write here 12 ohm. Okay. So now I have the circuit with a selected reference node And I already named the two other non-essential, the two other essential nodes. And as you see, the number of essential nodes is 3. You select one to be the reference, then we will have only 2 nodes with unknown voltages. And then we need to have 2 equations to solve this circuit and to find V1 and V2. And these equations actually are KCL. And KCL is Kirchhoff's current law. KCL is Kirchhoff's current law. So we need to write KCL for node 1, and then we will write it for node 2. And while you are writing KCL for any node, you need to consider that all currents are leaving the node, except the currents of the current sources, because they already have their direction. So we need to take their direction. So let's write for node 1. So what will be the current? This current is entering. And as we agreed before, that whenever the current is entering the node, its sign will be negative, and whenever the current is leaving the node, its sign will be positive. So this current entering or leaving node 1?
Entering.
So what will be its sign?
Negative.
So negative 4.5. Okay. And what will be the current through this 1 ohm resistor?
4.5 amps.
No. So how to express the current going away from node 1 through this resistor?
V1 minus 0 divided by 1.
Yes, exactly. So if you want to express all the other currents, you need to take the voltage difference divided by the resistance. So the voltage difference here is V1 minus the voltage at the reference, and the voltage at the reference is 0, and divided by the resistance, which is 1. So, and since this current is leaving, it will be positive. So positive or plus V1 minus 0 over 1 ohm. And what will be the last current, which is leaving the node in this direction?
V1 minus V2 divided by 8.
Yes, exactly. So we need to have V1 minus V2. This is the voltage difference divided by 8, which is the resistance. And this is, according to KCL, will be equal to 0. Now, if I rearrange this formula, so I have here V1 over 1, it will be V1, and V1 over 8, it will be 0.125 V1. So if you add them to each other, so you will have 1.125 V1. And for V2, it will be minus 1 over 8, it will be 0.125 V2. And if you take the negative 4.5 to the other side of the equation, so it will be positive 4.5. And this will be our first equation, So the first equation is 1.125 V1 minus 0.125 V2, and this is equal to 4.5. Any questions about this equation, please? Is it clear, please?
Yeah.
Okay. Okay, now we need to write KCL for node 2. And as we see that to node 2, we don't have any current sources connected, so we don't have any constants in this, but we need to represent all the currents in all 3 resistors through Ohm's law as a voltage difference over the resistance. So what will be the current which is leaving node 2 in this direction? So what will be the current leaving node 2 in this direction through the the 8 ohm resistor?
V2 minus V1 over 8.
Yes, V2 minus V1 over 8 plus what will be the current that is leaving the node downward?
That'd be V2 minus 0 over 12.
Minus 0 over 12. Thank you. And what will be the current which is leaving the node in this direction?
V2 minus 30 over 4.
Minus 30. V2 minus 30 over 4. Exactly. And this is equal to 0. And if we calculate these numbers, so I will start with the V1. So V1 here will be divided by 8. So it will be negative 0.125 V1. And for V2, I have here 1 over 8, which is 0.125 V2. And here I have 1 over 12, which is 0.45833. And here I have V2 over 4. So the sum will be the sum for all V2, it will be 0.45833 V2. And I will have here 30 over 4. 30 over 4, it will be 7.5 with negative. If I take it to the other side of the equation, it will be positive 7.5. So this will be equal to 7.5. And this is my second equation. So again, so 0.125 is 1 over 8 for V1. 1 over 8 for V1 with negative sign. This number is 1 over 8 plus 1 over 12 plus 1 over 4. So these are the coefficients for of V2. So it will be 1 over 8 plus 1 over 12 plus 1 over 4. And negative 30 over 4, it will be negative 7.5. If you take it to the other side of the equation, it will be positive 7.5. Is it clear how we get these two equations, please?
Yeah.
Yes,
Okay.
just to be clear, if you don't mind. So you just find the least common denominator, correct? And then, or that's really it, right?
Yes. So say it again, sorry.
Just find the least common denominator. So what, 8,
Yes.
12, 4, okay,
Yes.
thank you.
You're understood. Okay, and now I have two equations, this equation 1 and this equation 2. I need to solve them. So you can solve them by substitution, by elimination, or by matrix algebra, or you can use your scientific calculator. So here in this course, we are not, let's say, examining your mathematical skills. So you need to do it using any method you need. So if I solve these two equations, I will have V1 equal to 6 volts and V2 will be equal to 18 volts. So these are the two voltages. So V1 here will be equal 6 volts and V2 will be equal to 18 volts. And these two solutions, two numbers were the result of the solution of these two equations. This equation number 1 and this equation number 2, and these two equations have two variables, V1 and V2. Okay, so but this is not what is requested in this problem. In this problem, we need to find the voltage here, V, the voltage here, and the voltage here can be found using KVL. So I can use KVL in this direction. So I can write KVL in this direction, and then I can find this voltage. So I know the voltage across this 1 ohm resistor, which is V1. I need to calculate this voltage. This is my unknown, and the voltage across this 6 ohm resistor can be calculated by Ohm's law. So if I write a KVL for this green, so if I want to write KVL for the green, let's say loop, it will be, so if for KVL, if you go in the direction of voltage drop, you have positive sign. If you go in the direction of voltage rise, you will have negative sign. So this is the what we agreed upon. So I will start with the unknown. So V is unknown, and in this loop, I'm going in the direction of voltage drop. So it will be positive. So I will write V. And now I'm going through the 1 ohm resistor. And the 1 ohm resistor, the voltage across the 1 ohm resistor is V1. And the V1 has the following polarity. So we are going from the negative to the positive. So we are going in the voltage rise. So it will be minus V1. And then I need to have the current multiplied by 6. So it will be plus 6I, and this current is flowing in this way, in the direction of the loop. And this will be, according to KVL, equal to 0. So V is the unknown, V1 I know, which is 6 volts, but I don't know the value of I. So can I calculate I from the given data and the solution that I receive? Can we calculate I? What will be I equal to? So it will be according to, I have a response in the chat box, V2 minus V1 over 8. But can you please double check the direction? So I, according to our KVL, is this current, which is flowing from this point to this point. So what will be the direction for this I, or what will be the formula for this I? So this point is 1 and this point is 2. So it will be V1 minus V2, and over the resistance, which is the resistance, which is 8 ohm, right? Which is 8 ohm. So let me double check the, yes. So V1 minus V2. Okay. So, and V1 is 6 minus V2 is 18, and divided by 8, so it will be negative 12 over 8, so it will be negative 1.5 amperes. So this is the current. So I will go back to KVL and I will solve for V. So V is equal, I'll take the side of the equation, it will be positive V1, and then plus 6I, and I here will is sorry, minus 6I, because I'm taking 6I to the other side of the equation, so it will be minus 6I. And now I will plug the numbers. So V1 is 6 volt, minus 6 is the resistance value, and I is negative 1.5, and this will be, so if you do the math, so 6 times 1.5, it will be 9, negative 9, and negative it will be positive. So 6 plus 9, it will be 15 volts. It will be 15 volts, and this is actually the final answer. Any questions on this, please, method or this example? Any questions on this example, please? No questions?
Not for me.
Okay. So let us solve another example. Okay, I will solve, let's solve another example, and this example, we will have independent voltage source and with a supernode. So let's have the following circuit. Okay, so we have a voltage source, and after this voltage source is 12 volts. Then we have a resistor, then another resistor, then a voltage source, and this will be plus minus Ix, and then another resistor, and then another two resistors, and then a current source. Okay, so what we have, 12 volts we have here, 1 ohm, and 2.5 ohms, and 10 ohms, and 2.5 ohms. We have 7.5 ohms, and this is Ix, and that we have 4.8 amperes. So now all the numbers are there. Okay. So we need to solve this problem. Okay, we need to solve this problem. So let me ask a question. So how many essential nodes in this circuit? How many essential nodes in this circuit?
4.
4. How many nodes in general in this circuit?
I think that's 3.
They should be more than the essential nodes.
Wait, there's, I guess, 6 nodes total.
This is 1, this is 2, this is 3, this is 4, and here we have 5, right? So the node there is that connecting 2 or more simple circuit elements. We consider this is one node because we don't have any elements in between these dots. So this is one node. So we have in this circuit 4 nodes. This is one node. This is second node, third, 4, and 5. So these are 5 nodes. The essential ones are those nodes in which we have 2 or more, we have 3 or more simple circuit elements connected. So this is a 3, 1, 2, 3. This is a 3, 1, 2, 3, and this is 3, 1, 2, 3. While this one is 2, only 2. So this is not essential node. And the lower one connecting 1, 2, 3, 4, 5. So the lower node is connecting 5 simple circuit elements. Okay, so we need to select a reference. So where will be the reference? What do you think?
Bottom node.
Bottom node. Okay, thank you. Why do you think so?
It has the most elements connected and it's touching the negative of the voltage source.
Exactly. Thank you so much. So we are selecting this reference because it is connecting 1, 2, 3, 4, 5 components, and this is the most number of components are connecting to this node, and at the same time it is the negative side of a voltage source, which help us to know the voltage at this side. Okay. So what are the unknown nodes? So this will be 1. So we need to name them. So this will be 1, this will be 2, and this will be 3. So 3 unknown voltages. We have 3 unknown voltages, okay? And let me assign them. So this will be plus minus V1, and this will be plus minus V2, and this will be plus minus V3. Okay, any questions so far? Any questions so far? Okay, so we need now to write KCL, but before writing KCL, let's examine our nodes. So for this node 1, I see that we have a current source. We can express this current, and we can express this current. For this second node, I can express this current, I can express this current, but here I have another voltage source, and I don't know what is the current inside this voltage source. And although I know the voltage difference between these two nodes, but I don't know what is the resistance in this branch in order to express this current through Ohm's law. So what we can do, if you have a voltage source that is connecting to essential nodes, what will you do?
Supernode.
Supernode, exactly. So let me select a supernode. And supernode will be that node that is connecting the two nodes in between which the current source, the voltage source is connected. So this is a supernode. So what I need now is to write KCL for the first node and to write KCL for the supernode. So I will write here in green that this is a supernode. Okay. Okay. Now let's go and start solving the problem. So I will write KCL, Kirchhoff's current law, for node 1. And who will help me with that? So what currents are going to node 1? So we have one current, another current, and the third current. So what will be the first current? Again, the current which is going to the node is negative. The current which is leaving the node is positive. So the first current, the current of the current source, leaving or so it will be negative 4.8 in the chat box. Thank you. So negative 4.8. So this current source is going to the node, so it will be negative 4.8. Okay, what will be the current that is leaving the node through 7.5 ohm? Again, in the chat box, it is V1 over 7.5. Thank you so much. So this current, which is leaving this branch, it will be V1 minus the reference voltage, which is 0, and divided by 7.5. Okay. And now this current, which is leaving the node towards node 2, it will be V1 minus V2 over 2.5. So it will be plus V1 minus V2 over 2.5. And this is equal to 0. This is equal to 0. If I want to, I will arrange this equation later on. So any questions about KCL for node 1, please? Any questions for KCL about node 1?
No, not from me.
Is it clear? Let me hear your responses, please. Yes or no?
Yes,
sir. Yeah, it's clear.
Yes.
Yep.
Okay.
Yes.
Okay. So now we need to write KCL for the supernode. So KCL for the supernode. And we will use the same methodology. So what we have here, we will start with this current. So this current will be V2 minus V1 over 2.5. So this current will be V2 minus V1 over 2.5. And now I will write this current. And this current will be V2 minus 0 over 10. So it will be plus V2 minus 0 over 10. And now I will go to the other side of the supernode because I have only 2 here and I have another 2 here. So this current going downward, it will be V3 minus 0, the reference, over 2.5. So it will be plus V3 minus 0 over 2.5, and plus the last current, which is going in this direction, it will be V3 minus 12 over 1. So it will be V3 minus 12 over 1, and this will be equal to 0. So we have V2 over V1 over 2.5 minus V1 over 2.5 plus V2 over 10 plus V3 over 2.5 plus V3 minus 12 over 1, and this is equal to 0. So this will be my first equation. This will be my second equation. But how many unknowns we have in these equations? How many unknowns?
3.
3, which are
V1, V2, and V3.
V1, V2, V3. And we have only 2 equations. So
Right.
the third equation, you get it from inside the supernode. So always, if you have a supernode, the third equation, you get it from inside the supernode. So what we have inside the supernode, now we will see. From inside the supernode, let's have a look at the inside of the supernode. So I have here a voltage source, dependent voltage source, and this voltage source is current controlled because its value is given as a current. So the positive terminal is at V3 side, the negative terminal is at V2 side. So this means that V3 minus V2 is equal to IX. So from inside the supernode, I know that V3 minus V2 is equal to IX. But I see that I have the third equation, but in the third equation, I have an additional unknown. So now the unknowns are V1, V2, V3, and IX. So the unknowns are 4. So I need to get rid of IX. And I go back to the circuit and I figure out that IX is this current. And this current can be represented as what?
V1 minus 0 over 7.5.
Exactly. Thank you so much. So IX is equal to V1 minus 0 over 7.5. And from here, I will say V3 minus V2 is equal to V1 over 7.5. And this is my third equation. This is my third equation. Okay. Is it clear so far, please? Now, let's arrange the formulas. So here what I will do, I will divide 1 over 7.5 plus 1 over 2.5. This will be the coefficients of V1. The coefficient of V2 will be negative 1 over 2.5. This current source, negative 4.8, I will take it to the other side of the equation, so it will be positive. So if I do so, I will have the following equation. It will be 0.5333 V1 minus 0.4 V2. And I don't have V3, so it is 0 times V3. It's equal to 4.8. So this is my first equation rearranged. Okay, my second equation, now I need to collect the coefficients for V1, and V1 here is only 1, so it will be negative 1 over 2.5. So it will be negative 0.4 V1 And for V2, we need to add all the coefficients, 1 over 2.5 plus 1 over 10 plus that's it. So once 1 plus 2.5, it will be 0.4, and 1 over 10, it will be 0.1. So the total is 0.5 V2. And for V3, I will have 1 over 2.5 plus 1 over 1, 1 over 1. So it will be V3, 1.4 V3 plus 1.4 V3. And this will be equal to this number, which is 12 over 1. It will be 12. It has negative sign. If I take it to the other side of the equation, it will be positive 12. So this is the second equation. And in the third equation, as you see here, I have V1. I will take V1 to the other side of the equation. So it will be 1 over 7.5. It will be negative 1.3. So it is V1. Let me see V1. It will be what will be, please, 1 over 7.5. What will be 1 over 7.5, please? Okay, let me divide it, okay?
0.13333
Yes,
all the way.
okay, thank you so much. So it will be negative 0.1333 V1 and the plus 1 V2 minus 1 V2 minus 1 V2, here it is, minus 1 V2 and plus 1 V3 and the plus 1 V3, and this is equal to 0. So these are the three equations that we have here. So here the three formulas that we have. So if you use any method to solve them, we will find that V1 is equal to, let me see, 15 volts. And V2 is equal to 8 volts. And V3 is equal to 10 volts. 10 volts. So this is the solution if you use matrix algebra or a Kramer's rule to solve, or even your scientific calculator. So this is the answer for this question. Yes, yes, there is a question. Is this what it refers to as the constraint equation? Yes, it is the constraint equation from inside the supernode. So is it clear, please, this example?
Yes.
Okay. Any questions about this example? Okay, so let me ask how confident you will be able to solve such an example if you have it in the exam, please, from on a scale from 10, please. Okay, I see 2 responses, 8, 8, 8, 7. More responses, please, 8, 8, 7. Okay, more 7.5. More responses, please. More responses, please. Okay. Okay, and by the way, this is one of the most complex circuits. So if you will be able to solve this circuit, then I'm pretty sure that you can solve other circuits. Okay, so let's see what circuit we need to solve. Let's solve this circuit. Okay, so let's see this circuit. we will solve another example. Let me go to another page. And here we will have another example. So assume that we have here a dependent current source, and it is connected across a resistor. And here we have another resistor, and here we have another current source, and another resistor here, and resistor, and voltage source. So the voltage source is 50 volts, and the resistor here is 6 ohms. This is I1, and the resistor here is 8 ohm. And the resistor up there 2 ohms. The resistor to the right hand side is 4 ohms. The current source is 5 amps, and the upper current source is 3I1. So here we have this problem, and we need to solve it. We need to find the power associated with all sources, Okay, so we need to solve this problem. So again, my question again, how many nodes in this circuit?
Four.
4. So we have one here, this is 2, this is 1 here, 3, and the lower one is 4. Right, thank you. How many essential nodes in this circuit? How many essential nodes?
3.
3. So this will be one node, essential node, and this is will be another essential node, and the lower node is essential node. So this is not essential because we have only 2 elements connected to this node. So, and by definition, essential node is that node to which we have more than 3 or more. So here we have 4, here we have 4, and here we have 1, 2, 3, 4. Okay, which node will be selected to be the reference node? What do you think?
The bottom,
The bottom. Why?
because it connects to the negative side of the voltage.
Yes, okay. So although all these nodes have 4 elements at each node connected, but we select the bottom one in order to take the advantage of the fact
Sit down.
that, yes, please go ahead. So we need
sorry.
okay, so we need to take advantage of this voltage source which is connected here. So once this side will be the reference, then this point will be 50 volt, and it will be easy to express this current in this node. Okay, the next step, I will say this number is 1, this number is 2. I will assign the voltages V1 and V2. So these are the 2 voltages I have. Since I have 3 essential nodes, one of them will be a reference, and I will have only 2 non-reference nodes. And now I will start writing KCL to each non-reference node. And I will start with KCL to node 1, KCL for node 1. And again, the current which is entering the node is negative. The current which is leaving the node is positive. So what we have here, so let's start with this current. So when you are writing the KCL, you need to assume that all currents are leaving that node. But if you have a current source, you need to take it direction. So I have a resistor, so I will assume that the current is leaving. So what will be the current which is leaving in this direction? So what will be this current? So I see in the chat box, it's V1 minus 50 over 6. So V1, this is the voltage V1 minus 50. This is 50 over 6. Thank you. So V1 minus 50 over 6. Is it clear for all students, please? Is it clear for all
Yeah.
students? Okay. So what will be the current leaving the node through the 8 ohm resistor? So through this 8 ohm resistor, what will be this current?
V1 minus 0 over 8.
V1 minus 0 over 8. Thank you so much. And what will be the current leaving the node in the 2 ohm resistor?
V1 minus V2 over 2.
V1 minus V2 over 2. Thank you so much. And what will be the current going to the node 1 from this from this dependent current source? In the chat box, it says minus 3I1, and this is correct because this current is entering the node, so it will be negative. So it will be minus 3I1, and this will be equal to 0. So this is my first equation. This is my first equation. Now let's write KCL for node 2. So for node 2, and I will start with this current. What will be the current leaving node 2 in the 2 ohm resistor?
V2 minus V1 over 2.
V2 minus V1 over 2. Thank you. What will be the current leaving the 4 ohm resistor in the 4 ohm resistor? So in the chat box, it says V2 over 4. Thank you so much. So V2 minus 0 over 4. So I see that V2 minus the reference, which is 0 over the 4 ohm resistor. So of course, if you write the equation, you can skip the minus 0, but I'm writing it here in order to make sure that we all understand this. But once you will know that this is minus 0, you can skip it and just write V2 over 4. Okay, what will be the current which is entering node 2 here? It would be negative 5, I see in the chat box, because it's 5 ampere and it's entering the node, so it will be negative 5. And what will be the current which is leaving node 2 by this branch? So I see in the chat box a plus 3I1. Exactly, thank you. Plus 3I1, and this will be equal to 0. So how many variables we have in these two equations?
3,
3, which are,
V1, V2, and I1.
yes, V1, V2, and I1. And you see that either I will get rid from I1, I eliminated from these two equations, or I will have a third equation. So let's have a look. What is I1? Can I express I1 in terms of the other variables? Can I express I1 in terms of the other variables? So in the chat box, it says V1 minus 50 over 6, but I don't agree with that. So
it should be flipped. So it would be 50 minus V1 over 6.
yes, exactly. 50 minus V1 over 6. And I see that in the chat box, it is corrected. Okay, so why it is 50 minus V1, not V1 minus 50 as it was suggested by our classmate or colleague?
Because we're following the I1 current.
Yes, because we have a direction here. So the direction of I1 says that you need to deduct this potential, deduct this potential from this potential over 6. So the direction is going from the 50 to node 1. Okay, now if you plug 50 minus V1 over 6 here and here, then we will have two equations in terms of V1 and V2. If I arrange these two equations or solving them, okay, if I solve them, let me arrange them first. So these two equations will be the following. So from equation number 1, I will do 1 over 6 plus 1 over 8 plus 1 over 2 and the plus negative 3 multiplied by V1 over 6. If I add all these components for V1, so it will be 1.29167 V1. And now for V2, I will do negative 1 over 2. This is the only component for V2. So it will be 0.5 V2. And then I will take the let's say real numbers to the other side of the equation, which will be 50 over 60, negative 50 over 60, sorry, negative 50 over 6. And I have another number here, negative 3 times 50 over 6. So it will be equal to, I will take it to the other side, then it will be positive. So it is equal to 33.33. Okay, and this will be my first equation. The second equation, I will take it from here. So for V1, I have a negative half V1. And here I have positive, sorry, negative 3 V1 over 6, which means another half. So I will have negative V1, because we have negative half and negative half, so will be negative V1. For V2, I have half and 1/4 here, so it will be plus 0.75 V2. And then I will take this 5 to the other side of the equation, plus 3 times 50 over 6 to the other side of the equation. So it will be minus 20. So these are the two equations that I need to solve. If we solve them, so we will find that V1 is equal to 32 volts and V2 is equal to 16 volts. 16 volts. So these are the voltages, the unknown voltages here, okay? Now what I need to do is to find power associated with all three components. And I will go with the passive sign convention. And the passive sign convention says the power is positive if the current is entering the positive polarity of the voltage. So this is the voltage, this is the current, and then the power will be VI. So this is the passive sign convention. And if the result will be positive, then it will consume. If the result will be negative, then it will be, the power will be delivered by that element. So now I want, and the power, as you see, that is the product of the voltage and the current. So let's say start with this source. So in this source, I have 50 volts and I have a current. I will assume that the current is going in this direction. Okay, the current is going in this direction to fulfill the passive sign convention. So in order to fulfill the passive sign convention, I need the current to go in this direction in this source, and I need the current, the voltage here to be like this in this source. So the current, sorry, the opposite. So the current will leave the positive terminal. Let me see. The current is, sorry, the current is entering the positive terminal. Yes, the voltage will be like this. And for that current source, also the voltage should be like this. And I will explain each one in details. Okay. So this direction of the current and this polarity of the voltages are according to the passive sign convention, because as you see, the current 5 ampere is in this direction, and this is the simple circuit element. So if the current goes into the positive terminal and leaving the negative terminal, so it is according to the passive sign convention. Here is the same. We need the current to enter the positive terminal, leaving the negative terminal. And here is the current of this current source is also assumed to go into the positive terminal and leave the negative terminal. Okay. And now we know that, let me clear this side. We know that that the voltage is equal to I'm not sure that I can. Okay. We know that the power is the product of the voltage and the current. So what will be this current? This current is coming from node 1 to this point. What will be this current?
V1 minus, oh wait, if it's going to the left,
Yes, going to the left.
are we talking, so it'll be V1 minus 50 over 6, correct?
Yes, V1 minus 50 over 6. And V1 is 32 minus 50. It will be 18 over 6. It will be negative 3 amperes. Negative 3 amperes. Okay. And the power now for this source, the power for this source, let me write it here. I don't want to leave the figure. I want to be close to the figure. Okay, let me clear this part. Okay, and the power for this source, so it will be the power P of the source 50 volt, P 50 volt. It will be the current times the voltage. So the current is negative, or the voltage times the current, it doesn't matter. So VI, okay, and the V is 50, and the I is negative 3, and this will be negative 150 watts. This means that this source is delivering power. So this is the first source. Let's go now to the second source. The second source, let's say the 5 ampere current, 5 ampere. So this source. So this source, we need to multiply again V times I. So the current is obvious, equal to 5 amperes. And the voltage here is equal to the voltage V2, but as you see, opposite polarity. So here we have minus, but here we have plus, here we have plus, here we have minus. So this voltage across this, the voltage that assigned I in green here will be negative V2. And V2 is found to be 16. So it will be negative 16, and times the current, which is 5. And this will be negative 80 watts. So again, the current source will deliver power, And now the current, so the other current source, which has 3I1. So the current source 3I1. So again, the current VI, the power is VI, and the current here is 2 amperes. Sorry, it's 3I1. Sorry, the current here is 3I1. Okay, 3I1, and the I1 is negative 3. So it will be, the current is 3 times negative 3. Okay, so this is the current. So the current is 3I1, and the I1 is found to be negative 3. So it will be 3 times negative 3. And the voltage will be V2 minus V1, because the positive polarity here, negative polarity here. And V2 minus V1, V2 16 minus 32, it will be negative 16, right? So V2, yes, the current is, okay, so it will be 3 I1, and this is I1, V1. No, this is not I1. This is this current. I1 is positive 3. So positive 3 I1. So this current is the opposite current to I1. So if this current is negative 3, then I1 is 3. And the voltage is V2 minus V1, and this will be negative 16. And negative 16 times 9, 3 times 3, it will be 9, times negative 16, it will be negative 144 watts. Negative 144 watts. And again, this source is delivering power. This source is delivering power. Is it clear, please? Okay, so Travis, you still have a question? Okay. No, it's okay. Okay, so this is how to solve this problem. As you see that we solved these nodal voltages analysis, found V1, V2, and then you can find the power associated with any of the components of the components. So what else we can do in the remaining time? We still have 13 minutes. So let me see this example. Okay, so let me see this example. Okay, let me go one screen. Okay, so assume that we have the following circuit. And we have here one resistor, another resistor, and we have voltage source, minus plus, and here we have a resistor, and here we have voltage source, plus minus. So this voltage source is 10 volts. This resistor is 10 ohm. This resistor is 20 ohm. The upper resistor is 30 ohms. And in the middle, we have 40 ohms. And this voltage source is 20 I delta. 20 I delta. And here is I delta. Okay. So we need to solve this circuit. We need to find the voltages, okay? So again, how many essential nodes? Let me answer myself in order to save some time. So here we have one essential node, 3 components connected, another essential node, 3 components connected, third essential node, 3 components connected, and fourth essential node, 3 components connected. As you see here, we have the case when you have a voltage source connected between 2 essential nodes. So immediately I will select the reference node to be the lower one. So I will take the advantage of the fact that this voltage source is connected between 2 essential nodes. And I will assign the essential nodes as 1 and as 2 and as 3. And I see that V1, do you see how much is V1? Do you see how much is V1? I see in the chat box, it says V1 is equal to 10 volts because this is a reference, then V1 is 10 volts. So V1 is 10 volts. So instead of having 3 equations with 3 unknowns, then I have already 1 unknown. So I still have to discuss the other 2 unknowns. Okay. And what do you think? What is V3? What will be the voltage V3? Any idea about V3? Again, in the chat box, I see that it says minus 20 I delta. So minus 20 I delta. Okay, please have a look here, please. So this is V reference and this is V3, right? And here I have a voltage source. I will start with the positive minus the negative. So I will say V reference minus V3 is equal to this voltage. And this voltage is 20 I delta. Okay. I started from the positive, which is the reference, and the negative. Then V reference is 0 minus V3 is equal to 20 I delta. And then V3 is equal to negative 20 I delta. And this is what was in the chat box. So V3 is 20 negative 20 I delta. So now I know V3. So I need to write only one KCL to the node, the second node, because this voltage is known and this voltage is known. But I need also to express I delta in terms of the voltages, the unknown voltages. So what do you think? What will be I delta? Who can tell me what could be I delta here? So what will be I delta? Any ideas, please? Okay, so we see I delta here, and I know the voltage 10 minus 0, it will be 10, but I don't know any resistances, so I cannot divide this voltage on anything. But I still, if I cannot use Ohm's law, I still can use KCL. So I delta will be this current plus this current. And so I delta is equal to the first current, and the first current is V1 minus V2 over 10 plus V1 minus V3, which is, I will write it V3 over 30. Okay, is it clear for all of you? Yes.
Yeah.
It's clear. So I delta is equal to this value. And here I have also V3 that I want to replace it by this value, V1 by this value. So I delta will be equal to V1, which is 10 volts, minus V2 over 10, and plus V1, which is 10 volts, minus V3, which is minus 20 I delta, over the resistance, which is 30. Now I can rearrange this circuit. I can take I delta to the other side and do some mathematical manipulation, and then I delta from this equation, I delta will be equal to 4 minus 0.3 V2. 4 minus 0.3 V2. So this will be I delta. This will be I delta. Okay. So now I can take this value and put it here. So let me go here. It will be negative 20 times I delta. And I delta here is 4 minus 0.3 V2, 4 minus 0.3 V2. So now I see that V1 is given, V3 is represented through V2, and now I can write KCL for V2, for node 2. So now I will write KCL for node 2. And this is will be the last equation. So we have 3 currents. So this current is leaving this way, this current is leaving this way, and this current is leaving this way, knowing that this is V2 and this is V1 and this is V3. Okay, so what we have? We have V2 minus V1, which is 10, V2 minus 10 over 10. So V2 minus 10 over 10 plus V2 minus 0 over 40 plus V2 minus 0 over 40 and plus V2 minus V3 over 20. V2 minus V3 over 20. This is equal to 0. And now I can say, knowing that V3 is equal to negative 80 plus 6 V2 from here. So this will be negative 80 plus 6 V2. So this is V3. So now if I plug this formula in the place of V3, so I will have only one equation in terms of V2. And if I do so, so it will be V2 minus 10 over 10 plus V2 minus 0 over 40 plus V2 minus V3, which is minus 80 plus 6 V2 over 20. This is equal to 0. Solving this equation will lead to that V2 is equal to 24 volts. So V2 is equal to 24 volts. So V1 is equal to 10 volts. V2 is equal to 24 volts. And you can calculate V3 as negative 80 plus 6 V2. So V3 is equal to negative 80 plus 6 times V2, which is 24. So who has a calculator who can help us with this? So it will be 6 times 20, it will be 120. It will be 144. 144 minus 80, it will be 64 volts, I guess. Is it correct, please? Can you please double check?
Yeah.
Okay, so this is V3. So this is V2 and this is V3 and V1 is 10. So this is how to solve 10 volts, how to solve this problem. So and again, the three problems or the three problems that we solved are one of the most complicated problems. So if you understand these problems, I'm pretty sure that you can solve any other problem. And the problem that you have in the homework is one of the simplest presentation of the nodal voltages. Okay, we came to the end of the class. So if you don't have any questions, I will end the class at this stage. If you have questions, so please go ahead. So I have a question. What would the dependent sources actually be in real life circuit, like a transistor and relays and stuff? Yes, they could be like transistors. So if let's say the voltage across the transistor is one value, so it will be biased in some way. Or let's say if you have a chemical reaction for, let's say, a chemical battery, if you have a voltage across that battery and you have a chemical reaction inside that battery, so the current will be different. So there are different applications, but transistor could be one. Relays, maybe, yes, maybe relays can be represented as a source. So if you have the current in the coil of the relay, then you will have another current in the contacts of the relay. So it could be also represented as an independent source. Okay, so I will stop recording at this stage.